Good morning students. Today we are going to continue the Saturday topic, that is regression. Today we are going to study little more deep inside the topic, that is regression. So the topic included is regression line, regression equation and regression coefficient. So this topic regression, it comes under the paper 2 and a unit 2, that is statistical aspect, and the topic is correlation and regression. These both topics are given together. Here under this topic we have already studied the Pearson's coefficient as well as the Spearman coefficient. Today we have to study the regression line. So today's topic is regression line and related to their regression equations. So you know that regression, it is used to denote estimation or prediction of the average value of one variable for a specified value of the other variable. So it is one type of estimation or prediction of the average value, जिसमें हम एक वेरिएबल का एवरेज वैल्यू दिया रहता है, उसके अनुसार अगर अदर वैल्यूज का एवरेज वैल्यू क्या होगा, दैट वी यूज टू प्रिडिक्ट. So how this prediction can be done? This prediction can be done by means of suitable equation. हम क्या करते हैं, एक equation का use करते हैं. We used to utilize one equation, and according to that equation we used to determine the estimate or predict the value, average value. And this equation, suitable equation, is derived on the basis of available bivariate sorry for the interruption. So we are going to continue the topic, that is regression. It is done by means of prediction, can be done by the means of suitable equation. So we used to apply the variates on the equation, and these variates are, this equation is derived on the basis of available bivariates data. So certain x data is given and y variables are also given, and based on these two variables we used to predict the values, average values. Such an equation is known as regression equation, and these equations which we use to utilize for the prediction, this equation is nothing said to be the regression equation, and its geometrical representation is called the regression curve. So regression equation, the equation which is applied, that is said to be regression equation. Regression curve is a geometrical representation of the bivariates, and regression line we are going to study in detail. So what is regression line? So here you can find out the two graph where this x variable and this has the y variable. Y-axis, this is x-axis, this is y-axis. So here you can find out in the form of dots. So the variables, they are represented in the form of dots. In these are nothing but the correlation. But this is the regression line. So here bivariates are also present in the form of dots, but we used to select a particular line. From that line, most of the points they used to, normally you can say that they used to pass. So this is nothing but the regression line. So this is representation of regression, and this is the difference between the correlation and the regression. So here also we can find out the bivariate data, that is one on the x variable and another on the y variable. I hope you did most of the practical, that is estimation of potassium, estimation of SOx, estimation of NOx. Here we have given certain variables on the x-axis and we used to choose certain variables on the y-axis. Based on this x and y-axis, we used to conclude that this much concentration represents this much ppm, this much concentration represents this much absorption of the flame photometer. So here we used to take, in case of flame photometer, that is estimation of potassium, we used to take the concentration on the x-axis and we used to take the absorption on the y-axis. Here the concentration can be represented as 2 ppm, 4 ppm, 6 ppm, 8 ppm according to the grades what you have already prepared. And we used to get the absorption, that is flame photometer reading, on the y-axis, and accordingly we used to do the rest of the calculation. So what we are doing, we are just preparing a line that is nothing but the regression lines. So we used to prepare a line, and this is the line from where most of the points they used to pass. So we used to get the point somewhere here, but we used to draw a line from where most of the points they used to pass. So there we are utilizing this method, that is regression line method. So what is a regression line? If a bivariate data are plotted, bivariate data means two variables are plotted as points on the graph. ग्राफ पर जब हम प्लॉट करते हैं ग्राफ पेपर पर, it would found that the concentration point follows a certain pattern. जो concentration point है एक pattern follow करता है showing the relationship between the variables. ये जो pattern है वो हमें क्या दिखाता है कि एक relationship between the x variable to the y variable. And when these trend points, ये जो points होते हैं, are found to be linear, when these points are linear means they are following a particular path and that path is nothing but the linear, एक ही line में सारे points belong करते हैं. So when the trend points are found to be linear, we determine the best fitting straight line. हम क्या करते हैं, एक best fitting straight line को draw करते हैं by least square method. And such straight lines are used to obtain best. यही straight lines जो होते हैं वो obtain करने, best estimate को obtain करने में मदद मिलती है of one variable for a given value of the other value, and this is called said to be the regression lines. And these regression lines can also be determined by means of the formula y is equal to bx plus a. So if two variables are linearly related, always keep in mind that if two variables if they are linearly related, then that relation can be expressed as, this relation can be expressed as y is equal to bx plus a, where what is b? B is the slope of the line relating to y to x. एक slope होता है which is related to y to x, and what is a? A is nothing but the a is the y intercepts. A is the y intercepts of that line. So when we used to see the graph, then only we will come to know. So this is the regression line of representation where we used to plot one variables, x variables, that is independent variables on the x-axis and the dependent variable on the y-axis. Here we can find out a slope or you can say that this is a line. Okay, so we have plotted a line from which most of the points they used to coincide with the line. So if two variables are linearly related, we know that these which variables are linearly related, then the relation can be expressed. Now this relation can be expressed by y is equal to bx plus a. So this slope can be given by means of y is equal to bx plus a, where b, what is b? B is the slope. B is the slope of the line relating y to the x, and a is y intercepts. So this is y intercepts, and this is the b, and this slope is y is equal to a plus bx. This is x axis and this is the y axis. Or you can say that this is nothing but the representation of the line, regression representation of the line. Coming up to the regression equation. Normally this equation is of two types, that is regression equation of x on y variables, and that can be represented by this formula: x minus x bar is equal to bxy, x minus x bar is equal to bxy, y minus y bar. Or it can be represented as r, coefficient of correlation coefficient, whatever you say, delta x by delta y into y minus y bar. So here this is nothing but the x minus x bar is equal to bxy So this is nothing but x minus x bar is equals to bxy, y minus. So the regression equation of x on y bar or x on y can be represented as x minus x bar is equal to bxy, y minus y bar, or r delta x. This is nothing but the delta x by delta y into y minus y bar. So this is a representation of the regression equation of x on y variable. So always remember that if it is written x on y variable, so we have to consider here x variable and here should be the y variable. What is x? X is the value of the x variable. What is x bar? X bar is nothing but the mean of the x. What is dx over here? Dx is a standard deviation of the x series. And what is r? R is the correlation coefficient. So this equation normally estimates x for a given value of y. So if certain value of y is given, so we can determine the x from this data. So this equation estimates x. Always remember that this equation estimates x for the given value of the y. So while y value is already given, we have to estimate the x. Next is regression equation. Next regression equation is regression equation of y on x variable. So it can again, here x is substituted by means of y. So here we can find out the equation as y minus y variable is equal to byx. Here also we have did the same thing. x minus x variable is equal to b x y, y minus y variable. But here in case of x variable, we have to take it as, in case of here y variables, we have to take it as x variable. So y minus y variable is equal to b y x, x minus x variable, x bar, or it can be written as is equals to r. R is nothing but the correlation coefficient. dy is standard deviation of x series, and dx is the standard deviation of the x series. And x minus x bar, you know that x bar is nothing but an average. So this equation estimates y. Earlier equation that estimates the x, but this equation estimates the y for a given value of the x. So a particular value of x is given and then we have to estimate the y. Next is regression coefficient. So regression coefficient can be represented by means of the small letter b. So regression coefficient b is expression of how much one dependent variable y may be expected to change per unit change in some other independent variable. रिग्रेशन कोफिशिएंट एक्सप्रेस करता है कि एक डिपेंडेंट वेरिएबल में अगर थोड़ा सा चेंज आता है तो y में कितना चेंज आएगा. सो इट डिपेंडेंट shows, it expression shows how much one dependent variable may be expected to change per unit change in some other independent variable, and it can be denoted by means of small letter b. So always remember that regression coefficient can be represented by means of small letter b. So this is nothing but the regression coefficient, and the regression coefficient of y on x-axis. Remember, the regression coefficient of y on x-axis can be written as bxy, or it can be written as small r delta y by delta x. So what is delta y? Delta y is nothing but the standard deviation of y series and divided by standard deviation of x series. Next is, similarly we can estimate the regression coefficient of x series x on y. How this can be determined by means of the same formula, that is bxy is equal to, here we have to find out the regression coefficient of x on y. So we have to put the x on the numerator. X, what we have to estimate? We have to take this term on the numerator and this term on the denominator. So r, here x variable, therefore delta x by delta y. What is delta x? Delta is nothing but the standard deviation of x series. And what is delta y? Standard deviation of y series. So in this way we have to find out the regression coefficient. So these are the two equations for regression coefficient, that is regression coefficient of. So here you can see that the regression coefficient of y on x series can be written as bxy is equal to r This is sigma y by sigma x. Sigma y means what? Or delta, you can say that delta or sigma is altogether the same. But the main concept is that it is nothing but the standard deviation. So if it is y, then we have to write down the y on the numerator and then x on the denominator, because we have to find out the y. So here in case of the fourth point, you can say the regression coefficient of x on y, therefore we have to write down the x as a numerator over here and y as a denominator. Here we have to find out the y, therefore dx by here dy by dx. And if you are asked to find out the x, then you have to find out the dx by dy. In this way you have to write it down. What is dy? Standard deviation of the y series. What is dx? Is nothing but the standard deviation of the x series. Here in case of regression coefficient of x on y, here what is dx? Is the standard deviation of x series, and dy is standard deviation of the x series. In the next lecture we are going to solve by means of solving one example. Thank you. See you tomorrow.